Hi, so welcome to Module 1 of the course Data Science for Engineers, which is offered by the Department of Artificial Intelligence and Data Science. So we will begin with uh, an introduction to data science, which is actually what Module 1 is going to be. And let me give you a bird's eye view about what this module is going to be about. So to begin with, for any course, the first module, we begin by explaining the different terms that is involved in this subject. So we'll start with the definition of data science, its scope and its application. Then we will compare key fields which is related to data science. We will compare between data science, machine learning, deep learning, and artificial intelligence. We will also see the classification of data science into two, that is supervised data science problems and unsupervised data science problems. We will see how can we represent data and what are the major data types that is involved in a data science problem. And in the next part, we will see the different distance metrics in data science. And specifically, we will see the classical Euclidean distance, then Manhattan distance, Chebyshev distance, cosine similarity, Hamming distance, and Mahalanobis distance. So then we will go to an introduction to feature engineering, and to be specific, we will see feature selection techniques. We will see two or three major feature selection techniques. So that is all what module 1 is going to handle. So let's begin the course. So what do you mean by data science? So let's say what is uh, data science in terms of Wikipedia. So this is a small summarization of what Wikipedia tells about data science. It tells that data science is the study of how to use different methods and tools to understand and learn from data. It helps us in finding useful information from both structured or organized and unstructured or messy data. Kind of like finding patterns or insights from data. So if you summarize these into different points, we can just make five main points out of this. That is, data science, it combines the field of statistics, computer science, and domain knowledge. What do you mean by statistics? So the mathematical fundamentals that is required for data science is statistics and probability theory. And a bit of linear algebra would also help. And then we should know the fundamentals of computer science. We should know what is algorithm, fundamentals of complexity theory, and then the domain knowledge. That is very important. So it's a different vertical. When we talk about domain knowledge, what I am trying to tell is we should know that what is the domain of the data. So it can come from verticals like maybe healthcare, it can be from finance, it can be from pharmaceutical. So you need to have some knowledge about the domain because the data would be coming in terms of sheets or CSV files with some headers. Headers are essentially the column names. So you should be in a position to understand that what each column names means. So that will be very domain specific. And also you can tell data science focuses on extracting insights and knowledge from data. So that is the main thing that we are aiming from data science, right? We try to make conclusions from data which can help us in our business, whichever business it may be. Any vertical you are working, we can draw insights that can be useful. And data science will work with both structured and unstructured data. So what is unstructured data? Let's see. Unstructured data is like what we have in web, like the comments that we get in social media, in YouTube or in say in Twitter, in Instagram, the comments, right, that people are writing. So that is unstructured data, and organized data or structured data is the data that is coming in tables. It can be coming as relational tables, or it can be coming as CSV files, and there can be dependencies between these files. Some files can be metadata, but all in all, it will be structured. It will be having a structured format, right? So data science should work on both structure and structured data. And then if you think about tools, we should be using tools from data mining, machine learning, maybe something from algorithms, and mainly data visualization also, because we should need something to uh, something to represent this data in a very simple format, right? So we need some visualization tools also for that. So this visualization part will be covered in the last module. And finally, the point that comes that is related to data science is it helps in making data driven decisions across industries. So this is something that we might have covered in the second point, that is it focuses on extracting insights and knowledge from data. But why, what kind of insights? Insights should be helpful for the industry, right? So it helps in making data driven decisions across different verticals, right? So that's how we make a business out of data science. That's how these days data science is such a hyped word. The end product is mainly finance. There will be financial gain from the insights that we are getting from data. Okay, so let us see how a typical data science process works. So this is a flowchart that is provided by O'Neill and Schutt. So you can refer to their textbook if you want to know more about this. But we will more than just having a bird's eye view. I'll explain each and every part of this network flow, like how it starts and how it generally ends. So first of all, we want to collect data. Data can come in different formats. It can be coming in text format, like the unstructured data that I was speaking about just before. And it can be coming from comments from YouTube videos, or Twitter, or Facebook, right? So those are text in text format. So we can also get data in a very structured format, like it may be some information about patients, like their vitals. It can be about their BP information, about the different comorbidities they are having, but it's very structured. Every row of this table will be uh, concerned about a single patient. Or data or can also come in other many other different forms. It's not just the text and tables. Data can come in audio format, video format, but then it requires a lot of different techniques to process it. So that is the second part. Data is processed. So if it is coming in video or audio, essentially this data science machine learning algorithms works on numerical data, right? It should be in terms of numbers. It should not be in terms of text. So there are ways in which you can embed these different types of data into their um, numerical embeddings, right? So uh, you make the data in such a way that it can be understood by the machine learning model, by your data science model. And then see, you can send this data to be cleaned, because the data that we are having, there may be a lot of anomalies, a lot of missing data. So there are algorithms that will take care of this. It will make the data clean, and after that we can send it to an exploratory data analysis phase, where we will get the first level of insights about the data. We will get to know that what is the variance across the different features, what feature is important for predicting the output, and those kind of things. We can know more about the data. We can have visual interpretations also about the data, right? So if you are not satisfied with the way in which the data is looking, then we can again go back to the data pre-processing step. That is, data is again processed, and then again we clean, and this process goes on until we are satisfied with the hygiene of the data. So after that we can move to the modeling phase where we will use data science models and data science algorithms to model this data for our required task. Maybe we are predicting something, or maybe we are grouping the data into different clusters. So whatever it is, we will employ some algorithm, and this entire uh, process will make a machine learning model or a data science model which can give the desired result, right? And then once we are having the model, an accurate model that we are satisfied, we will communicate the results in terms of visualization. We can show the results, the numbers in a very visually pleasing manner. And finally, if these things are going well with the with the head of the company and all, then they can move forward for making this data science model into production. So that is a very big task. There it should be scalable. If you are going for a B2C, a business to consumer product, then a lot of task is involved in this. So making machine learning model, that is one task, and making it into a product is another task. And in this subject, we will be handling the part where we are making a machine learning model. Okay, but just so that you understand, so data product, that is a big phase. There's a lot of different technology and a lot of different effort that goes into this phase. And after that, it goes to the world. So we took raw data from the world, we built a machine learning model out of that, or a data science model out of that, and finally we built into a product and we give it back to the world. So this is, we can say this is a life cycle for a data science problem. So why now there is such a big hype about data science? Yeah, why? I mean, data was available before also, but not in this quantity. Yeah, that is one of the main thing. Like everywhere we have data now. Massive amount of data is there because of sensors, because of the digital data that we are having. Everybody has mobile phones, and all the data, most of the data is recorded, right? So we have a lot of data. And the second thing is computing power. The kind of RAM size that we have in our mobile phones itself is like exponentially more than what we had before, let's say 15 years before. And so, the computing power has become much cheaper because of the advent in the hardware. And so, it's like very inexpensive in terms of computing power. And then proliferation of small footprint, low power sensors. Yeah. So now we have the technology where we can, uh, embed sensors which are very lightweight in the system, and it will leave very small footprints. It's very lightweight, and the sensors will be sensing the data and feeding that data into the backend, into the cloud or whichever platforms. And then there is this feedback loop between our behavior, the environment, and the data product. What do you mean by feedback loop between our behavior? So just think about like how things are working, how the culture is uh, working now. Like most of the people have mobile phones, they have social media accounts, they have Instagram accounts. So with that, a lot of data comes into picture. So the culture plays a role there. Everybody has their personal space these days. They have their own social media accounts, and these companies who are profit driven, of course, they are finding a gap. Like they are getting this data. They are able to get this data from your behavior, and from that, they can change your behavior. That's why from the data, behavior, environment, and data product, it again goes back to behavior. That's why feedback loop. So how it goes back, because once they make this data product, it may be something like Netflix or YouTube suggestions. They will suggest you some uh, links or videos based on your historical preference. They are obviously using machine learning and data science models for this, and they are giving back this to you. So again, you follow their suggestions. You may follow, may not follow. So with that, again, you are giving new data to them. So this will keep on going, until uh, we can generate profit. So that is another reason why data science has become so popular these days. So generally how a data science team would look like. So individual data scientist profiles are merged to make a data science team. So a data science team, like the team profile should align with the profile of the data problems to tackle. So if you think with the traditional software industry profile, right? The profile of data science team. This is very different in terms of data science problems. It's very different from a software developing point of view. So you can see in the left, bottom left, you can see some of the domain names. So there is a person who should be handling the data visualization part, who should be creative and who should have very good knowledge about the different visualization tools. And if you're using Python or such kind of, they should be aware about that too. Maybe different tools, R, Python, etc. And then there should be people who are good in machine learning. There should be people who are very good in statistics and mathematics. There should be people who are good with computer science to make sure that um, the complexity of algorithm is something that we can handle. Then people who are good in networks or communication, people who are good in explaining this problem to the client, right? So that comes under communication, and who can make good networks and good leads, right? So, and then domain expertise, that is very important. It depends on which kind of data you are handling, right? So if you are handling healthcare vertical, there should be somebody from that vertical. If you are handling a different vertical, there should be somebody from that vertical. So this very different types of people combines together to form a data science team. So for different products or different kind of data science problem, the people that works in this project can also change. For example, domain expertise. If a finance problem comes, there may be a person who is expert in the financial domain. If a healthcare problem comes, there will be a expert from the healthcare domain. So all these people are necessary for the successful completion of a data science problem, right? And you can see what EMC data science study suggests. You can just see from this 3D pie chart, like if you're interested, you can just have a look at it, like how this uh, their population, the population of the different majors. You can see majors from computer science, majors from different disciplines, right? How it is being distributed. Yeah, different types of data scientists. So there is machine learning scientist, there's statistician. So these are all, you can tell that's kind of like alias in the field of machine learning. If you see the designations of people who are working in the field of data science, somebody can be called as a machine learning engineer, and if they shift their job to another company, they can have a different label, like data science engineer or AI scientist or data scientist. Right, but all in all, like even though you changed from company to company, um, the general tool set that is required to work on data science problems remains almost the same. Right. Okay, so just for your interest, I've just put some of the famous uh, data science job descriptions across different companies. So, what do data scientists do? Right. So you can think about that as two-sided problem. That is, let's think about academia and industry. So if you're talking about academia, generally the person works on a huge amount of data, and it will be computationally, those problems will be very hard. So the person should have a experience not just about a deep knowledge about machine learning, might require a very good fundamentals of computer science, and the data may be very unstructured, and you have to do proper research to find out what kind of machine learning algorithm you have to use. And you might have to come, if it's a research oriented project, you might have to come up with research solutions also for that. But if you are thinking in terms of industry, the data science problem would be motivated by mainly because of the profit that is involved. So you have to extract meaning from the data. Um, they may not care about like what kind of algorithm you use. It's all about if you are able to make better predictions and better insights from data, all is well. The depth or the complexity of your problem doesn't matter. Generally it doesn't matter in industry, but the output that you are able to get from your work, right? So that is kind of the difference. In academia you generally go very deep, but in the industry, since you are going to solve a real world problem, right? So you might require a very broad knowledge, not a in-depth knowledge. So that is kind of the difference between what data scientists do in academia or in colleges versus what they do in industries or companies. Okay, so that's all about session one. We will continue in session two. Thank you.